Hello and welcome to the second week of the course. This is the lecture slideshow for Philosophy of Science. This week our slideshow will cover Chapter 7 of the Akasha text and Handout 1, especially sections 1 through 7. Be sure to read these before reviewing these slides extensively. The next slideshow next week will cover the remainder of Handout 1. There's going to be one slide set released at the beginning of each week with the exception of Thanksgiving week. Read the first handout on the Canvas homepage for this course. Introduction and Why People Respect and Distrust Science, sections 1 through 7. Again, read Chapter 7 and then Chapter 1 in the Akasha text. As usual, visit the blog page, which I update weekly, usually on Mondays. So here's our question. Why do people respect and distrust science? Every disaster movie starts with the government ignoring a scientist. There are really two questions here. Why do people A, respect, and B, distrust science? So let's break this down. Why do people respect science? Two reasons. Here's the argument. Science is useful and interesting. Scientific investigations promote understanding the cosmos and ourselves. Scientific reasoning justifies beliefs based on testable observations and experiments. Scientific methods explain complex phenomena and predict events. Science produces technological innovations that improve the human condition. If all of those claims are true, then science has great practical and intellectual value. And so science does have practical and intellectual value. I think this is undeniable. Science has ethical values that establish its credibility as well. Deviations from these values undermine its authority. What are ethical values? These are ideals that promote human flourishing. These ideals guide behavior, social norms, laws. Here are the main ones. Honesty. Honesty is required for truth-seeking. Integrity. This is a kind of consistency of character and methods. Doubt. Yes, a value in science, perhaps the biggest value, the strangest value, is that doubt is required. First, you doubt what people tell you. First, you doubt what you think you're experiencing, seeing. Always verify. Never just trust. Respect observation. Standards of evidence. Expertise. Accountability to the community. Not just the scientific community, but the community at large. Expose fraud. Transparency of data, methods. We want to enable repeatability of experiments, observations. There also needs to be openness to alternative, testable explanations of data. We'll say more about each of these, as we go through the course. Americans' confidence that scientists act in the public interest is actually increasing. 6 in 10 Americans say scientists should play an active role in policy debates about scientific issues. The source of these data I consider to be, pretty much the best, the most reliable, is the Pew Research Center. This comes from August of 2019. Who should we trust? This is an important question. When should we believe what authorities, witnesses, friends, and family assert? People say, trust, but verify. But is that a good idea? Philosopher Onora O'Neill offers a useful definition. S, your subject, some person, is trustworthy if and only if that person is honest, competent, reliable. Information should be accessible, usable, accessible. Science requires this. Here's what Onora O'Neill says. More trust is not an intelligent aim in this life. Intelligently placed and intelligently refused trust is the proper aim. Well, one says that, you say, yeah, okay, that means that what matters in the first place is not trust, but trustworthiness. It's judging how trustworthy people are in particular respects. I think that judgment requires us to look at 3 things. Are they competent? Are they honest? Are they reliable? And if we find that a person is competent in the relevant matters and reliable and honest, well, we'll have a pretty good reason to trust them because they'll be trustworthy. But if, on the other hand, they're unreliable, we might not. Why do people distrust science? Here are 5 reasons. I call these the top 5 reasons why people distrust science. There are more. Science is awesome. Science defies common sense and challenges established worldviews. Scientists make contrary and even contradictory claims. Science is hard to do and assess. It is especially difficult for non-experts to understand. Scientists doubt or reject what most people believe. Let's look at each of these in turn. Science is awesome. What do I mean by this? Medical innovations such as vaccines, antibiotics, painkillers, contraceptives, antidepressants, magnetic resonance images, and mammograms extend our lives while making us more dependent upon them. Consider GMOs, genetically modified organisms. Many people believe they are more beneficial, they feed people, than harmful. They are risky. But also many people disagree. Who should we trust? How do we resolve the pros and cons? A genetically modified organism is any organism whose genetic material has been altered using genetic engineering techniques. Most of our food has been genetically modified. For example, soy, corn, canola, cotton, milk, sugar, squash, papaya, rice, bananas, strawberries, tomatoes, beans, livestock, etc. Some people think GMOs are bad because their harms outweigh their benefits. Some people think they're good because they think benefits outweigh the harms. For instance, genetically engineered crops currently on the market appear to be as safe to eat and safe for the environment as organic or conventional foods. This is the opinion of Professor Pam Ronald, a genetic and plant pathologist at UC Davis. I have a video that I want you to watch by her. The video is called The Case for Engineering Our Food. If you can't find it in Canvas or on the blog page, which you should be able to find it there, just Google the YouTube video, I think it's a TED Talk, The Case for Engineering Our Food, Pamela Ronald. What I want you to look for is this. What is the main argument that she, plant pathologist and geneticist Pam Ronald, presents in her video? What are the reasons for her main point? What are some benefits of GMOs, according to researchers such as Pam Ronald? What is her argument for the production and use of GMOs? Continuing the point, science is awesome. The products of science are impressive, powerful, and dangerous. Scientific knowledge and understanding inspires technology. It gives us the World Wide Web, smartphones, supercomputers, spacecraft, robots, and weapons of mass destruction. Our lives are easier and more connected than those of our ancestors. Progress in science costs us much in privacy, security, and freedom. Science enables people to do immoral things. Smartphones are cool, but drones and clones are scary, and killer robots are in our future. Science produces weapons of mass destruction. Consider what happened to Hiroshima and Nagasaki in 1945. Science progresses by upsetting and superseding old worldviews. Scholars in ancient and medieval times believed Earth was the fixed center of the cosmos, that there are only as many basic, unchanging kinds of organisms as God separately created, and that there are just 4 elements which comprise everything, namely earth, air, fire, water. The history of science is a tale of numerous rejections of old beliefs. Further, nobody really thinks disease is caused by angry gods or evil demons anymore. We now treat mental illness without trepanations, that is, drilling holes in our head, or exorcisms, that's the casting out of demons by magical or priestly incantations. Another concern, people have the impression that science flip-flops. Here I refer to the classic example of the big change in our view of the cosmos, in particular our solar system, where up until about, I'd say, reliably, up until about the 1600s, most people believe, and most scientists believe, that Earth was at the center of the cosmos. And that view radically changed within 100 years. It became the idea that we realized that actually it looks like the sun's at the center of the cosmos, and our planets of our solar system, go around it. So again, the top 5 reasons why people distrust science. Let's focus on the second one, namely science defies common sense and challenges established worldviews. Seeing is believing, but collective experience tells us not to believe everything we see. Common sense says that whatever happens occurs for a reason, but physicists say otherwise. Modern physics says that some events are uncaused, when we can't help but think that everything in every event has a cause. For example, subatomic particles can come into existence and perish by virtue of spontaneous energy fluctuations in a vacuum, physicists say. Contrary to popular belief, biologists now say that birds are dinosaurs. They're not merely derived from dinosaurs or related to dinosaurs. They are their living descendants. And that humans are actually apes. We're not merely cousins, we are among the great apes. People in the past were just as sure about their beliefs as people in the present. But strong faith and certainty are not reliable indicators of truth. Here's the philosopher Nietzsche. A casual stroll through the lunatic asylum shows that faith does not prove anything. For almost 2,000 years, physicians practiced bloodletting to cure disease. Some still do. Now, withdrawing massive amounts of blood from the body kills more people than it heals. Retired President George Washington woke up at 2 a.m. on December 14, 1799, with congestion and a sore throat. He died after his doctors had drained nearly 40% of his blood. Top 5 reasons why people distrust science. The third main reason. Scientists make contrary and even contradictory claims. Mainstream reports of scientific findings, often distort the significance of some research, especially conclusions based on small samples or low-quality preliminary studies. Also, bad science makes headlines in part due to the politics of science itself. Often a specialist in one discipline, say a cardiothoracic surgeon, with a popular television show becomes an authority on nutrition for the general public. Beware the authoritative non-expert. Physicians sometimes get the science wrong. Some doctors are scientists, but most are not. But physicians are perceived as credible, a fact exploited by industry and marketing. Doctors once recommended smoking. In the 1930s and 1940s, smoking became the norm for both men and women in the U.S., and a majority of physicians smoked. In the 1950s, advertising campaigns featured doctors telling people that smoking was safe. By 1954, industry strategists thought physician images in advertisements were no longer credible in the face of growing public concern about accumulating evidence for the hazards of smoking. Another example, for generations, and through prohibition in the 1930s, physicians prescribed alcohol as medicine. A referendum on alcohol in the practice of medicine prepared for the U.S. Congress in 1922 revealed that over 50% of physicians surveyed continued to describe spiritus fermenti, or whiskey, wine and beer, as a necessary therapeutic agent for treating things like influenza, pneumonia, heart failure, shock, anemia, diabetes, cancer, asthma, dyspepsia, snakebite, lactation problems, and old age. But few good randomized controlled clinical trials on even moderate alcohol consumption and mortality outcomes has been done. The medicinal benefits of alcohol have yet to be found. We must fact check all sources of information. But when is the last time you looked at scientific literature? Now they tell us that there is no safe level of alcohol consumption. Researchers recognize alcohol use as a leading risk factor for disease burden, and studies link its consumption to 60 acute and chronic diseases. Now, risk factors are not causal factors. To say that something's a risk factor is only to say that we see this association between people who consume alcohol and people developing these particular diseases. In the interpretation by the study authors, this is what they found: that alcohol use is a leading risk factor for global disease burden and causes substantial health loss. We found that the risk of all-cause mortality, the risk of all the things which can cause you to die, increases. That is, the risk of such things as cancers rises with increasing levels of consumption. And the level of consumption that minimizes health loss is zero consumption. These results suggest that alcohol control policies might need to be revised worldwide, refocusing on efforts to lower overall population-level consumption. This comes from the paper Alcohol Use and Burden for 195 Countries and Territories, a systematic analysis. This is published in The Lancet 2018. Here's the reference to that. So alcohol can cause 7 types of cancer. I want to say a little bit about what it means to say that alcohol causes cancer. Not only do they find associations or correlations, in these cases, after randomized controlled trials establish that there is this actual correlation between consuming alcohol and subsequently developing these cancers, then researchers actually induce these bad outcomes, these cancers, for instance, in lab animals, to show that, in fact, not only is it a correlation, but it's actually a causal connection. Here are 4 ways alcohol causes cancer. This has been shown in research. It actually damages cells and increases damage from tobacco consumption. It amplifies the negative effects of tobacco use. It affects hormones linked to breast cancer. Alcohol breaks down into cancer-causing chemicals. Here's a little description on one way alcohol increases cancer risk. So the other thing that researchers have found, established, seen over and over in various animal models and humans, basically it looks like alcohol sets off a chain of reactions that precipitate in the body producing cancers. The alcohol and breast cancer risk increases in proportion to how much you consume. No alcohol is less, and the more you drink, 6 units a day, for instance, it looks like there's a higher association, higher likelihood of developing the cancer. Okay, here's some other claims, recent claims, where science seems contrary to either previous findings in science or more established scientific claims, that is, claims produced by the scientific community in the past. Low carbohydrate diets are better than low fat diets, studies show. Used to be what people believe. This claim, if true, contradicts previous findings and recommendations to reduce fats more than carbohydrates in one's diet. What are we regular people supposed to believe when authorities change their mind? Here's an answer. Investigate the claim yourself, always, as much as possible. Doubt by default. See my articles about issues discussed in class, link within Canvas, within the first module, for more examples and sources from current scientific literature, current scientific research. Let me say more about that example of low-carb versus low-fat diets. The low-carbohydrate diet, in the most recent, largest, best study we have thus far, the low-carbohydrate diet was more effective for weight loss and cardiovascular risk factor reduction than the low-fat diet. Look at these graphs on the change in body weight. Okay, returning to our top 5 reasons why people distrust science, here's the 4th. According to me, science is hard to do and assess. It's especially difficult for non-experts to understand. What do we mean by that? Well, most of us can't easily check whether what scientists say is true. Scientists study complex, difficult to observe phenomena. They do so by drawing finer distinctions than common sense and ordinary language permits. Without advanced training, or at least a college course in inductive reasoning or statistics, most people who acquire a scientific conclusion from a non-expert, a secondhand source, the media, can't process it competently. This does not mean we should just believe what scientists say. Some questions here that you're perhaps familiar with, currently debate. Is global warming, climate change real? If so, are humans a major cause of it? So here's the question, and here is the famous hockey stick graph. Perhaps you've seen this. And what the graph is doing is representing data from thermometers and from tree rings and corals, ice cores, and historical records that allow us to track the change in temperature within the past 1,000 years. Pretty much the change in temperature doesn't deviate much more than, say, half a degree for about 1880 years. And then suddenly there's a sharp rise in the average, and sharper still around the year 2000 and into the year 2020 as well. We see a really high increase in the amount, the change in temperature observed. Again, we must always ask, who is competent? Who is reliable? Who is honest? The second question, is global climate change human-caused? It looks like it because atmospheric carbon dioxide has increased substantially, dramatically, uniquely since the Industrial Revolution. Here's the chart. For 650,000 years, atmospheric carbon dioxide has never been above this line, which it surpassed in 1950 and now is way above. The current level now is way above. And what we're talking about here is carbon dioxide parts per million in the air. This graph, these data come from the National Oceanic and Atmospheric Administration. Look, we like stories, not statistics. Ordinary people trust people who seem sincere or confident. We rank personal experiences, feelings, and testimony highly. But scientists rank such evidence as unreliable and easily corrupted. In science, any claim or hypothesis is incredible if it can't be falsified, checked by a controlled experiment. This means tested with the possibility of being rejected. It's not enough to find evidence that's consistent with what you believe or predict. It's not enough to observe what would be the case if you predict, for instance, that humans are causing global climate change. You also have to make observations which would rule out that hypothesis, which would show it's false. Look, if we thought global climate change was not real, what would we see if we were right? We would see no dramatic deviation in temperature or atmospheric CO2. But we do see those things. Actual scientific findings are difficult to assess, but we should do it. We should strive to do it. Use science databases such as NCBI or PubMed to check claims. Do an online search with terms that narrow the field to higher quality sources. For instance, you want to drill down and find journals, publications. For example, type in PubMed and then type in low carbohydrate diet versus low fat diet, or low carbohydrate diet versus low fat diet, meta-analysis, randomized controlled. These keywords will get you the better studies, those where they controlled for various things like, biases, sample size, random errors. I want you to see a couple of graphics that I have on handout 1. One is called The Rough Guide to Types of Scientific Reasoning, and the other is called The Rough Guide to Spotting Bad Science in handout 1. It's not true that all science is good, some science is bad. This will help you. Oxford Professor of Primary Care Health Sciences Trish Greenhalgh in 1997 produced a nice series of very short must-read articles on how to read a paper at the British Medical Journal website that explains how to interpret different kinds of research papers. Here is the URL on this slide. Scientific fraud and poor oversight also happen. Retractions of papers, of publications, correct some of this, but retractions are rare. Few studies and their results are repeated. This is why we need to follow up and allow scientific experts to check each other's work over subsequent months and years. Many, if not most, scientific papers get rejected for publication. See reasons why in this article, How to Read a Paper, Getting Your Bearings, Deciding What the Paper is About. Don't just trust scientists. When relevant experts do a research study, even if they publish results, we can't just conclude that their findings are accurate or reliable. Don't trust reports, and especially reports about reports. We certainly should avoid accepting second-hand media stories about their work. In my experience as someone trained in science and logic, almost every time I find the original published studies, I see gross errors in journalistic and other media accounts of the research. This is what that British Medical Journal page on the web looks like. These titles linked to short papers I think papers I want you to look at. In particular, papers that go beyond the numbers, papers that summarize other papers. Reason 5, among the top 5 reasons, according to me, why people distrust science. Scientists doubt or reject what most people believe. For instance, most people believe in supernaturals. What are those? Well, most people believe in angels, ghosts, gods, demons. People believe that angels visit, guard people. Ghosts haunt people. Demons make us behave badly. Gods make and destroy worlds. Most people across the world, this is not just America, think that supernaturals explain events, but scientists don't. For scientists, supernaturals, while possible, are superfluous, that is, unnecessary for explaining events. This is why so many are atheists. Let me be really clear about this in a Pew Forum study of what people believe versus what scientists believe. 95% of Americans believe in God, but most scientists don't. And by God I mean, and I mean something in particular, I mean the God of Abraham, Isaac, and Jacob as described in the Hebrew Bible, Genesis, Exodus, etc. Also in the New Testament, I should say, Matthew, Mark, Luke, and John. Notice that the general public's belief in God the prevalence of belief in God vastly surpasses that of scientists. This is not to say that all scientists are people who don't believe in God. Certainly some do. Albert Einstein, for instance, in 1954 had this to say: "The word God is, for me, nothing more than the expression and product of human weaknesses. The Bible, a collection of honorable but still primitive legends, which are nevertheless pretty childish." Now, that's pretty harsh. Here's Stephen Hawking in 2014. "Before we understand science, it is natural to believe that God created the universe. But now science offers a more convincing explanation. What I meant in my book, A Brief History of Time, by saying we would know the mind of God is we would know everything that God would know if there were a God, which there isn't. I'm an atheist. An atheist is a person who believes there are no gods. They're not sure, they just don't believe in them. Science rejects faith and demands testable evidence. Its predictions are dire. All of this alienates scientists from non-scientists. They're so negative. When beliefs are threatened by new facts, people tend to believe more strongly what fits what they believe already. Emotional reasoning and confirmation bias affect negatively our ability to evaluate scientific evidence. I'll talk more about emotional reasoning and confirmation bias in later lectures. So when scientists tell us what we don't want to hear, we are dubious. Because in general, when people tell us things we don't want to hear, we think they're wrong. Maybe it's wishful thinking, maybe it's defensive thinking, I don't know. The way we doubt what other people tell us that's contrary to what we believe already is really the way we should approach every claim, even those claims made by people with whom we agree. Bottom line, why don't people like scientists much? Why are they so annoying? We don't want to listen to people who are so negative all the time. Another example, a majority of Americans hold creationist views of human origins, but over 95% of scientists do not. And a creationist view would be the idea that humans were created by God, or God used a process to create humans. Your basic creationist is someone who believed God had some essential part in the making of humans. Someone who is not a creationist, for instance, an atheist, or a person who is agnostic, who has serious doubts, who remains to be convinced, is someone who thinks that, well, maybe a God was involved, but maybe not. Okay? True or false? Human beings, as we know them, developed from earlier species of animals. And you'll notice on this graphic from Science, an article in 2006 on the public acceptance of evolution, you'll notice that the United States is pretty far down on the list of people who actually believe that humans developed from earlier species of animals. Why is this? In the United States, the acceptance of evolution is lower in the US than in Japan or Europe, largely because of widespread fundamentalism and the politicization of science in the United States. Again, we're trying to explain why people believe what they do. We're not saying whether anybody's right or wrong here. So there are major gaps between the public, scientists, on key issues. Despite broadly similar views about the overall place of science in America, it's useful, it's interesting. There are striking differences between the views of the public and those of the scientific community. See my chart in handout 1. Is the growing world population a problem? Lots of scientists say yes. Much of the public says no. Are foods grown with pesticides or genetically modified organisms safe to eat? People in general do not believe that these are safe. Whereas scientists who study these sorts of things, who've done safety trials, who have deliberately tried to find the harm, deliberately tried to produce the harm that genetically modified organisms might cause, disagree. Should vaccines be required of school children? As you know, parents, people at large disagree on this, but the vast majority of scientists, especially epidemiologists, believe vaccines are wise. Are science and religion compatible? Well, this is a can of worms we'll return to in the last 2 or 3 weeks of the course. Certainly some science and some religion is compatible. I'm talking here about mainstream religion, Judaism, Christianity, Islam, and, well, mainstream science. Religion is regarded by the common people as true, by the wise as false, and by the rulers as useful. This is attributed to the philosopher Seneca, the Roman philosopher Seneca. Are science and religion compatible? Let's talk a little bit about that. One of my favorite questions people raise in debating whether or not humans are related to apes, let alone actually apes, is, well, if humans came from apes, why are there still apes? And this is something I think is worth asking Google, researching yourself. I'm just saying, if we evolved from wolves, then why are there still wolves? My Labrador Retriever says. Are science and religion compatible? Even religions disagree. And I have a chart from the Pew Forum on Religion and Public Life, which studies religion, which depicts the percent of people within a particular religion who accept that evolution is the best explanation for the origins of human life on Earth. And on the far left, you'll see that 81% of Buddhists surveyed agree that evolution best explains the origin of human life. And as we move down the chart, we go from Buddhism, Buddhist, Hindus, Jewish people, unaffiliated people. Now, these would be everybody from non-believers to doubters, to people who don't have a particular faith, perhaps New Age religions, etc. That's at 72%. Then we get to 58%. Now we're looking at Catholics, Orthodox Jews, mainline Protestants, and now we're dropping below the 50% level when we talk about overall those Muslims, historically black Protestant churches, evangelical Protestants, Mormons, and Jehovah's Witnesses. Science tells us what we don't want to hear all the time when they release studies, when they publish. Here are a few examples. I feel like these are the extracted main points or headlines of various publications. Genital herpes, HSV2, is now detectable in roughly 1 of 5 persons, 12 years of age or older nationwide. I remember when this came out, 1 in 5 people, that means 20% of people. Basically, for every 5 people, or if you've got 100 people, that's going to be, 20 out of 100 people are going to be positive for genital herpes, 12 years of age or older. I simply did not believe it when it came out. I'll tell you what stood in my way. I didn't know anybody. I've only known a few people in the time since then that actually have it. But here I realize I'm a prisoner of my own perceptions. Lots of people don't know they have genital herpes. And if they know, they're not going to tell people. It's not something we publicize. These researchers pretty much just tested a whole bunch of people, like several 100,000 people, and found that the prevalence was basically 1 in 5, 20%. Another finding, not welcome, routinely rejected. Exposure to sexual content on television predicts teen pregnancy. That is, teens exposed at high levels are twice as likely to become pregnant within 3 years. This is not saying that watching television causes this, but there's some sort of relation between television watching and teen pregnancy. Television watching with sexual content. It is not safe to drive a car and carry on a phone conversation, even if one uses hands-free devices. Researchers, you're aware of this probably now. Researchers have fairly well demonstrated that you actually, in the absence of a person in a room talking to you, it's very difficult for your brain to switch and process and amplify and understand what people are talking to on a electric device. Further, motorists who talk on cell phones while driving have been found to be as impaired as drunken drivers, with blood alcohol limits at the legal limit of 0.08%. This is from the Journal of the Human Factors and Ergonomics Society. Look, I admit I have, tried to use a cell phone I've successfully used a cell phone while driving. I usually have been successful, but I have occasionally had near misses. I have stopped doing this. Perhaps you've noticed this as well. The reason people believe they're safe is that they haven't had an accident yet. Another reason contributing to the apparent safety, but overall on average, it's an illusion. Another thing that contributes to the apparent safety is everybody else is looking out for people when they drive. In other words, other people are paying attention as well. And in many cases, probably one day a week at least, if you're driving on the freeways, you're avoiding accidents. You're avoiding crazy driving. Nevertheless, the idea here is that texting, talking on the phone while driving diminishes your ability to pay attention. Still more from the Science Tells Us What We Don't Want to Hear files. I'll just give you the sort of headlines. The popular botanical ginkgo biloba does not improve memory, nor does it prevent cognitive decline in older people. In this study, what they did was they said, okay, so what would we see if it does improve memory, and what would we see if it doesn't? Well, they had a group that consumed the ginkgo extract, and they had a group which did not consume the ginkgo extract. In that group, they consumed something that tasted similar, the same. In other words, the people didn't know what they were getting, what group they were in, and they failed to detect a difference, cognitive decline in memory capabilities in the two groups, between the two groups, where you otherwise would expect to see a difference. That is, you'd expect to see less cognitive decline and an improvement of memory if the ginkgo biloba was a difference between the two groups. Inhaled cannabis is more toxic than tobacco smoke. I know people will deny this. It contains 20 times as much ammonia and 5 times as much hydrogen cyanide as tobacco. Nitrogen oxides known to affect the circulatory and immune systems are 5 times more concentrated in cannabis smoke. Again, the claim here is not that tobacco smoke is safe or that there are not amounts of cannabis consumption that are relatively safe. It's just saying that it's at least as toxic. Rather, inhaled cannabis is more toxic than tobacco smoke because of all these contaminants. Did you know? Easy to deny, but did you know that smoking just 1 cigarette a day can increase 3 times the risk of heart disease or lung cancer? Just 1 cigarette. This is so hard to grasp, so hard to believe. Does just 1 cigarette a day triple the risk? So those are the top 5 reasons why people distrust science, and when I refer to these in the remainder of the course or on quizzes, these are what I'm talking about. I want you to be aware of these. Certainly you probably can think of your own. I wanted to give you the top 5 as I see it. All of those, I think, are rational reasons. We don't fault you for thinking these things. You've got, reasons for thinking this. All of these, I think, are rational reasons to worry about how seriously we should take science, scientific claims. But science challenges our faith in tradition and the status quo, the way things are. This makes people distrust it because people must choose between the old ways of thinking, the comfortable habits we accumulated over the years, our personal experiences, or the new ways of understanding the world and our place in it. If science sometimes tells us what we should believe, we need to be clear about what counts as a credible belief, a truth and knowledge, and we'll get to this. So here's a big problem. Science is atheistic. It's done without reference to any gods, any supernaturals, any unobservable, untestable entities. Science defies common sense, and let's face it, it disrespects traditional stories about the world. For instance, conventional medicine routinely scoffs at non-mainstream, non-Western alternative medical therapies. There is a deeper problem, an underlying problem. Faith-based thinking is in constant conflict with evidence-based thinking. These are incompatible. More about this later. I want to make some comments on some other ideas raised in Okasha's Chapter 7. In Chapter 7, Science and Its Critics, Okasha makes the case that certain attitudes within and outside of science undermine its authority. Now, it's simplistic and unfair to the process of science to think that only science explains phenomena, or that science alone is the only legitimate road to knowledge. Most scientists are naturalists, but few are scientistic. That is, believe scientism. I'm going to have to explain what all that means here. What follows on the next slides are some technical terms describing default assumptions shared by most scientists and philosophers, although few are committed to any of them. I prefer not to use these terms as people use them in so many different ways that they confuse and mislead us. I prefer to use the phrase which I think best describes what the term means, after much thought and consideration. Let me tell you what I mean. Again, science is not perfect, and it's not the only way to acquire knowledge, but it's very useful. The trouble is, scientists are routinely accused, and I think unfairly, of believing science is perfect and the only way to know about the world. It isn't. There's other ways. There's logic. There's math. There's poetry. There's music. Yes, religion perhaps. Let's talk about the concept of naturalism. This is the general idea that probably, for lack of evidence, only natural entities and forces operate in the world as opposed to supernatural or spiritual ones. This is not the denial of supernaturalism, it's just the opposite. There is no need to presume that anything exists beyond the observable natural world. Science is the best way to understand reality. It's not a substitute for common sense, but it's an extension of it, the philosopher Willard Van Orman Quine noted in 1957. There are two forms of naturalism here. It's important to contrast them. They are compatible. Now, neither implies the other. Again, don't look at the terms themselves. It's jargon in the philosophy of science. Look at what they stand for. So there's this idea called ontological naturalism. This is the idea that nothing divine, supernatural, or immaterial exists, because there's insufficient evidence to think so. There's methodological naturalism. That is, we can describe and explain what we observe without referring to anything divine or supernatural or immaterial or non-physical. Scientific methods can't or should not assess supernatural claim. And this is not because people are closed-minded. This is because we basically can't get a hold of them. We can't observe them. We can't manipulate them. I think it helps to read the article by David Papineau, a philosopher, the entry on naturalism in the Stanford Encyclopedia of Philosophy. It's quite extensive. I'd read a little bit until it becomes, really difficult or not very interesting anymore. But I think it's good to get an idea about what an expert who spends a lot of time thinking about this has written in what's considered a peer-reviewed journalistic account of the idea in general of naturalism. Here's some more isms to watch out for. Again, you don't have to accept these to do or trust science. They're floating around. It's how philosophers and people who criticize science typically refer to the attitudes or background assumptions of scientists. Materialism. This is the idea that nothing exists except atoms and empty space. This is more or less the same as something called physicalism. That is, whatever exists is physical or made of matter. It's the idea that matter and space is all there is. Everything else is opinion. And this is ancient. This goes back 2,000, 2,500, maybe 3,000 years. Scientism. This is kind of a new word. This is the attitude that science is the only legitimate description and explanation of reality. It's the only reliable source of knowledge. Now look, scientism is a kind of naive science worship. Yeah, there are people who zealously follow science, but to be fair, it's inaccurate to say that all or even most scientists presume this. Often the term is used to dismiss scientists as closed-minded atheists. Few scientists actually believe that all important questions can only be answered by science. Nevertheless, we ignore scientific findings at our peril. For example, most scientists prefer to explain disease by reference to observable microorganisms, virus particles, rather than unobservable gods or magical forces or divine plans. Chapter 7, Okasha makes the case that science is not value-free and mentions the tension between science and religion. I described ethical values in science that establish its credibility and how deviations undermine its authority. Review that list. I have a little more to say about this beyond the observation that most of these values are not unique to science, as they are shared by civil society. What is the exception? Doubt. Science values doubt above faith. The often adversarial relation between science and religion is an issue we return to in the last 2 weeks of the semester. This is why I need you to read the text Science and Religion, Are They Compatible? By Daniel Dennett and Alvin Plantinga before the final weeks of the course. Up next, watch this video. There is a link to it in Canvas. It's called The Alternative Fix. Here are some questions about the video Alternative Fix you should be prepared to discuss. I'm going to ask you these in a discussion. What are some arguments that proponents of alternative medicine give? That is, among the people who advocate using alternative medicine, what are the reasons they give for using alternative as opposed to mainstream medicine? Number 2, in your view, are these arguments good or bad? Why? Give me your reasons. This is the end of slideshow 2 for week 2.